Hello everyone. Today we are going to see the WireShark type of IP. So first we have to know what is meant by IP and how this IP protocol is used in the computer networking and what is this use of the IP networking and how this IP networking is useful for the internet and how the communication is going to be easier even by using the IP networking. So we are going to see in this lab. My name is Shivakumar. Today we are going to see IP. So what is mean by IP? IP is nothing but the internet protocol. It is a fundamental protocol used for the communication across the internet. It enables the transfer of the data packets between the devices. Means from the internet, the data is stored in the databases. So when you are going to type any IP address like 198.66.2, then it is directly redirected to the database. The information will be then directly redirected to the customer receivers. Then these also used to as like a TCP. So now we have to know what is the importance of IP networking. IP is play an essential role in networking by providing the unique identification and addressing to the devices. What is the work of this IP? IP use the specific or a unique number or a unique ID that is directly we can identify this is the ID of this company or this is the ID of this software. So which is provided by the one IP is going provided by the that unique ID and addressing to the devices. Specific enable and efficient data transmission. It is also useful in the data transmission from the different communication devices. So how we are going to capture this package in the WireShark? Threshold is a diagnostic tool used to measure the route taken by the package to reach a destination. So in this package, in the WireShark, we are going to capture the packets of this IP. But using the a software called as a pin plotter, we are going to trace out the uh, packets. So first we have to know what is meant by the pin plotter. So, pin is a network troubleshooting and a diagnostic tool that visualizes and solves the internet connectivity issues. It monitors the connection between your computer and a packet server and provides detailed report on a packet loss, latency, and other potential issues. So, what is the use of the pin plotter? Pin plotter is used in the networking. That's when there is an issue or error occurred. It is used as an error correction or error detection tool. So, it can be resolve the errors which are made by the connection of the networking. So, in this IP, in this WireShark lab of the IP, WireShark lab of IP, we are going to use the pin plotter. That is to trace out the packets using the TTL. TTL is the time to live. That is, we are going to trace out this packet by using the pin plotter. So now, I am not going to use a pin plotter. So I will use a WireShark that is directly by using a file called as given by the WireShark lab. So I am going to download this file, zip file. Then I am going to extract all the files. So I have already downloaded the file. Let's see the file. So here I have downloaded the file. So now I am going to use this file. In which this file I am going to use this file to be using this file. I am going to trace out all the packets of the ICMP and IP. So now we directly go into the WireShark. So first go to the files. Now we are not going to select any of the filters here or any of the networking traffic rules. So directly we are going to open. So I am going to select the IP tracer. So why I am going to select this one means they have selected. They said go to IP ethereal trace one only. So I am going to select this one. So then I will be open. So I have selected all this one and all the packets are captured according to the different protocols of the IP and ICMP. So next what they have set, then we go to. So look at the capture trace. So same I have got like this. So now what they are saying, filter. See the scenario of ICMP. So now we have to see the filtering package here. Now I am going to use the display filter ICMP. So here you can see different type of the protocols of the ICMP are captured here. Then what they have said, we are going to answer the question directly now. This is also already heard. Now what is first question? Select the first ICMP echo request message sent by your computer and expand the input protocol part of the packet window. First is echo, that is ICMP echo request message. Protocol. So this is the first ICMP request. I am going to select this one. And this one. So I have selected this one. First message. So then what is the question they are asking? What is the IP address of your computer? So address is 192.168.1.102. My IP address is that one. So here you can see 192.168.1.102. Same I have got here. So next question. Within the IP packet header, what is the value in the upper layer protocol field? In the IP packet header, what is the value of the upper layer protocol field? So the value is ICMP1. So here you can see the protocol. The protocol is ICMP1. So in the packet header, this is the packet header, this is the ASCII code letter, and this is the packet capturing. So I have got the protocol is ICMP1. So what is the third question? How many bytes are in the IP header? How many bytes are in the payload of the IP datagram? Explain how you determine the number of the payloads. So here you can see I have got 20 bytes in the header bytes, and total number of data bytes is 64. Means how we are going to see now. So here you can see I have 20 bytes. They are asked for the header length. Header length is 20 bytes and the total length is 84 bytes. So what I am going to do for getting the total number of the packets, I am going to do 84 minus 20 is equal to 64 bytes. So I will get the 64 bytes of the data payloads. So we are going to the next question. Has this IP datagram been fragmented? Explain how you determine whether or not the datagram has been fragmented. So the IP datagram is not fragmented. If fragmented flag is not set, then the datagram is not fragmented. If fragmented flag is set, then the datagram is fragmented. So now we are going to see. Here you can see the fragments offset is equal to 0. So here now fragment is set. So that's why I have it. It is not fragmented. So the fragment mode, don't forget, and fragment is 0. So we are completed the question. Now we are going to the next question. So this is some of the information that we are going to listing the package using the ICMP. So you can do that one. So which field in the IP datagram always change from one datagram to the next within the series of ICMP messages sent by your computer. So the identification field, ETL or time to field or header section field. These are the three fields that are going to change always from my datagram or the ICMP message sent by my computer. So these are the three fields are constantly changing. So here you can see time to live, ICMP1, time to live, and header checksum. These are the three fields which are going to continuously changing. That's why this identification field also. So you can see now the identification field is 40316. So here you can see now the identification field is 13008, and time also is changing. So that's why I have said these three are changing continuously. So which field stays constant? So the following must stay constant. Which field must change and why? So for this one we can see that source address is changing, and see this also stay constant. Destination address is constant, header length is constant, and IPOS is constant. Because the source address of my computer is always constant. It is not changing. Here you can see 192.16. Here also same. Here also same. And the destination address also it is continuously not changing. That's why I have said the source address, the destination address, header file, and the IP version are not changing. They are staying constant. Display the pattern receiving the values in the identification field of the IP datagram. Seventh question is about the IP datagram fields. I see that the value of this field is increased by 1. So every time it is increasing by 1. Here you can see time to live. The result ETL value is 1. If I select another, this is now increasing by 1, 5. If I select second one, the time to live is 1, 255. So it is continuously changing. So it is increasing by 1. Here you can see every time it is not same. It is the checksum value and the iteration value are continuously changing. Both so they are not constant. Now we are going for the 8th question. So for the 8th question, we have to find the series of the ICMP TTL exceed replace symbol in the computer to the nearest first to proto. So what is the value in the identification field and the TTL field? They are asking for the identification field and the TTL field. They are asking for the value means they are asking for the identification. So here you can see this is the TTL field. This is the checksum field. So this is the identification field. What is the value of the identification field? 13008. This continues changing. 13009. So if I select the protocol, 13017. So it is not continuously changing. It is not staying constant. These values remain unchanged for all the ICMP except replies. So you can see that is for this one I have got 244. The identification field value is changed, but TTL remains unchanged. So the time to live is unremained and the identification value continues changing. That is the issue here. Now we want to know what is mean by fragmentation. So first we have to know what is mean by fragmentation and what is the use of this fragmentation in the IP networking. So first we have to know what is mean by fragmentation. What is mean by fragmentation? Unraveling the concept of fragmentation. Here the packets are divided into smaller fragments to fit within the maximum transmission unit, that is MTU operated networking. So if there is a large number of the files or large set of the data, it is not going to fit, it is overfitted. So that's why what we are doing using the fragmentation. Fragmentation is nothing but dividing up the packets into smaller size of the datagrams. So it can be fit into the any number of the networkings. So this is the use of the fragmentation. So here you can see the transmission of the data is high, then we use the fragmentation. What is this impact of the fragmentation on the network performance? It shows a great impact. So fragmentation uses increasing overhead. It reduces the throughput and also need for the additional processing. So if the data is large, it is not going to fit for everywhere. So we need this fragmentation. This fragmentation controls the data by dividing into smaller parts and also reduces the throughput. So the threshold value. So now we are going to see how this fragmentation works in the WireShark. So find the first ICMP echo refresh message and so was sent by your computer after you change the packet size to importer. So I have not used the importer, so that's why I have used here this zip file and I have extracted and I used the IP3 present package. So here you can see what they have said IP echo message request. So go to this protocol, then request. So the response is into the request. So they have asked you for the internet protocol identification, that is 13020. I have got 13020 and value is flag star received bit is not set and this is frame set is equal to 0 for this one. So this internet protocol can say identification of the section is 0xEA and the data I have got is 56 bytes I have got for this one. Here you can see the length is 56 bytes. So that section status is good. So some data only I have out here also. So first find the first ICMP request. Yes, two fragments. So I have got first I have got the 2000 bytes and second I have got the 56 bytes. So now I am going to check for the number of fragments I have got. So I have got the 4 fragments and 2 fragments here. Here you can see type 8 echo ping request. So ICMP request. The number of fragments I have got is 2 here and time to live is 12. Header file is 0x2221. Here you can see the destination address and the source address also. So now we are going to question number 11. Print out the first fragment of the data fragment IP data graph. What is information in the IP header indicates? So in the IP header of the first fragment, the more fragment flags are set. It indicates that it has another fragment. So we are going to check for the protocol. This photo ICMP. Check for the photo ICMP. This is TTIP1. The checksum and it is time to leave 1 and the protocol is so I got is time to leave only 1. The protocol ICMP is 1. Here you can see the sequence number and switch number. So the flags are fragments are not set, different flags are not set. So what I have got here is the fragment is not set. The datagram length is I have got is 1480 bytes long. So now we are going to question number 12. Enter the second fragment of the fragment IP datagram. What information in the IP header? So they are asking for the second fragment of the datagram. So the request, there is no response. Reply. Second reply response. So what they are asking for the second request frame is 2D122. Here you can see the request frame. They ask for the second datagram. So here you can see I have got the two frames. I have got the two frames here. That is frame count is 2 and decimal equivalent is 2008. I have got 2008 bytes. Here you can see. So what they ask to enter the second fragment, the IP datagram. So this is the IP datagram, second data IP datagram. So what I got is 2008 bytes here and the offset is the interface will be offset. Now we are going for the second question. What fields change in the IP header between the first and second fragment? So this is the IP header. They are asking for the what it is going to change and what it is going to be unchanged means change constant. The fields are total length, flags, more fragments and fragment offset. These are going to change. They are not going to be constant in the from the first frame to second frame. Here you can see in the first frame I have got 1500 bytes. In the second frame I have got the 548 bytes. So they are not staying constant. They are continuously changing. So that's why I have wrote for the these are the four things which are going to change. Now, for the 14th question, we are going to use the ICMP for display message. That is, if you use the pin plotter, then you have to change the size to packet size to 2500. So I have not used the pin plotter here, so I am not going to change any value. So for every time, I have got only 2000 bytes. So how many fragments we created from the original datagram? From the original datagram, I have got three fragments. Here you can see the three diagrams, three frames, what I have got, and what are the payloads, and what is the identification number, and what are the TTL value. Here you can see, for the second time I have got two fragments. That is frame 133 and frame 134. The frame count is 2 and the IP4 length is 2008. So every time it is not constant and the TTL value is 1. It continues to change and the fragment offset is 14.8. So we are going for the last question and the 15th question. What fields change in the IP header among the fragments? So what they are saying in the 15th question, what are the fields is going to change in this field? Means it is a header field, it is the ASCII code field. So what are the field is going to change? The fields which are going to change are the total length, flags, more fragments and fragment offsets. That from you can see here, and for the first fragment I have got 1500 bytes and for second fragment I have got some more less than. So these are the fields are going to be changed in the header files for the third one. So this is the user the IP in the importer IP of in the WireShark lab, and this is the tracing of the WireShark lab using ICMP, and you can also trace the IP value also. So here you can see the IP value. So what are the IP present? Here you can see.